So we have seen what are trigonometric ratios, their reciprocals. Now we move on to trigonometric identities. When we say an equation is an identity, means it must be satisfied for all those angles for which the trigonometric function is defined here. So the first one is sine theta into cosecant theta is always going to be 1. Whatever may be the angle theta, right? The identity sine theta into cosecant theta equals to 1 is always going to be true. So from this, I can say cosecant theta, I can bring sine theta to the RHS. So cosecant theta equals to 1 by sine theta. The same goes with the other. I can write sine theta equals to 1 by cosecant theta. Second, cos theta into secant theta is 1. So secant theta is the reciprocal of cos theta, or I can say that cos theta equals to 1 upon secant theta. Next, tan theta into cot theta equals to 1. That is, cot theta is the reciprocal of tan theta. The same goes with tan theta equals to 1 upon cot theta. Next, we have just discussed this, tan theta is sine theta by cos theta. This is always true, but keep in mind this angle theta must be same. You cannot have a different angle in the numerator and another one in the denominator. Sine theta by cos theta is always going to be tan theta. Next, cos theta upon sine theta is nothing but cot theta. Now, when we actually get into solving the sums, we might have to use the LHS to RHS or RHS to LHS. So both the ways you must be able to remember. Next, this is the most important identity, that is sine square theta plus cos square theta equals to 1. Very, very, very important identity. Now, once we remember this, if I want the value of sine square theta, just transpose cos square theta, or if I want cos square theta, just transpose sine square theta. From this we can derive the other two formulae, that is sine square theta is 1 minus cos square theta and cos square theta equals to 1 minus sine square theta. Okay, so coming back to those formulae, let's repeat them again. Sine square theta plus cos square theta is always going to be 1. Next, sine square theta is going to be 1 minus cos square theta, cos square theta is going to be 1 minus sine square theta. Next one, we have 1 plus tan square theta is secant square theta. Or I can write that as tan square theta equal to secant square theta minus 1, or secant square theta minus tan square theta equals to 1. So the first one, sine square theta plus cos square theta is 1, and here secant square theta minus tan square theta equals to 1, right? So the next one, 1 plus cot square theta equals to cosecant square theta. Observe here, it is 1 plus tan square. So this is 1 plus cot square, tangent, cotangent, secant, cosecant. So 1 plus cot square equals to cosecant square theta. Next, from this I need cot square. So transpose 1. So we have cot square theta equals to cosecant square theta minus 1. Next, from this I can write it as cosecant square theta minus cot square theta equals to 1. Right? So these are the most important identities, and these needs to be memorized. If you know the ones which I've put in the box, as you see, we can write down the other values. Okay, so these are the trigonometric identities that we would be using going forward. Now let's look into some of the examples just to get the understanding how to apply all these. Let's say we have a triangle PQR. In a triangle PQR, what is the condition? Just read the question. In a triangle PQR, right angled at Q. The right angle is at Q. The side PQ is given to be 3 centimeters, PR is given to be 6 centimeters. We need to find the angle QPR and angle PRQ. Now QPR is nothing but finding out the angle P. Angle PQR is same as finding out the angle R. Okay, so let's see, this is a right angle triangle. Let's represent this point as P. It's already given that it is right angled at Q. So I'm just writing this here and let this be R. Now you need to find out this angle and this angle. What are the other conditions given to us? PQ is given to be 3 centimeters and PR is given to be 6 centimeters. So in this triangle PQR, we are given one side, the hypotenuse, and we are asked to find out this angle R and this angle P. Okay, so now from this triangle we know we need to find out this side, right? So the side opposite is given. What do we call this as? The perpendicular, and this is the hypotenuse. Sin theta is nothing but, get back to the formula. Sin theta is the side opposite to the given angle by the hypotenuse, or I can say the perpendicular by the hypotenuse. So sin r, what is the perpendicular here? PQ upon PR. Now just substitute the values. What is PQ? PQ is nothing but 3 and PR is nothing but 6. So sine of the angle R is nothing but 3 by 6, which is half, right? Now coming back to the angles that we just learned, sine 30 degrees is going to be half. So this angle R is going to be 30 degrees, right? So angle R is going to be 30 degrees, or in short I can say angle PRQ is going to be 30 degrees. Now how do we find out this angle? You don't have to find out this side. We know that in any triangle the sum of the angles is going to be 180 degrees. So here the triangle is PQR. So I can say that in a triangle PQR, angle P plus angle Q plus angle R is 180 degrees. We already know that angle Q is right angle is 90 degrees. Angle R we just found out, that is 30 degrees. Just substitute it here. So what does it come up to? Angle P plus 90 plus R is 180 degrees. 90 plus 30 degrees, that is 120 degrees. So angle P plus 120 degrees equals to 180 degrees. Just transpose 120 degrees to the RHS. So angle P equals to 60 degrees. That is, in short, this angle, right? This is what we have to find out. The angle QPR, this is nothing but 60 degrees. Right? Let's look into one more example. Right. Prove that secant A into 1 minus sin A into secant A plus tan A equals to 1. So look into all the values here. We're just going to consider the LHS part first, simplify and show that it is equal to 1. So secant A. So secant of any angle is 1 upon cos. Secant is 1 upon cos, reciprocal of cos. So secant A could be written as 1 by cos A. Next, which are the other values that we can simplify further? Tan A. Tan A can be written as sin A by cos A. So this is the step that we are going to simplify. We took the LHS, secant A, right? We are going to change, write it as 1 by cos A. This goes undisturbed, we'll bring it down, 1 minus sin A. Secant A plus tan A. Secant is written as 1 by cos. So secant A is 1 by cos A and tan A is nothing but sin A by cos A. Now, don't disturb the first two terms. We're going to bring it down as it is. Take the LCM of these two. Observe that the denominator is the same. So I can just add up the numerators, 1 plus sin A by cos A. All these are product. So multiply. Here I can multiply these two. Cos A into cos A, bases are same, the power will increase. So cos A into cos A can be written as cos square A. So these two terms will be left as it is. So 1 minus sin A into 1 plus sin A by cos A. Now if you look at this, right, we have an algebraic identity, that is A plus B into A minus B. That can be written as A square minus B square. So this is 1 square, which is 1. Minus sin A into sin A is going to be sin square A. So 1 minus sin square A by cos square A. Now we want to get 1. So which is the numerator? 1 minus sin square A. Get back to the identities. We know that sin square A plus cos square A is going to be 1. Right? Or sin square theta plus cos square theta is 1. Angle, I told you, these two should be the same. Whatever you are denoting, they have to be the same. So sin square theta plus cos square theta is 1. Now here instead of theta, it's just the angle A. So here from this 1 minus sin square A, if I just transpose this here, what do I get? Cos square theta is 1 minus sin square theta. So this is going to be 1 minus sin square A. In the place of theta, we have A. So 1 minus sin square A could be written as cos square A. These two will cancel. We have here 1, which is nothing but the RHS. So which is the most important part here? Writing secant as 1 by cos reciprocal, tan A as sin A by cos A. This identity which we already have learnt in other chapters, a plus b into a minus b is a square minus b square, and the standard identity sin square theta plus cos square theta equals to 1. So now this theta, it could be a, b, c, alpha, beta, gamma, any angle, the way you want you can represent. But in the given question, this theta is represented as a. So I'm just going to recollect it as sin square a plus cos square a is 1. So 1 minus sin square a could be written as cos square a, that is nothing but 1, right? So this proves that LHS is equal to RHS, alright. Let's look into one small example again, one more. Right, we need to prove this. Cot A minus cos A by cot A plus cos A is cosecant A minus 1 by cosecant A plus 1. So consider the LHS because that's easy to simplify also. Both the ways you can do it. So LHS cot A minus cos A by cot A minus cos A. Now which is the easier one to replace? This value cot A can be written as cos A by sin A, right? Now what else can we do from this? Two ways. One, you can go with the LCM and then take out common, or observe here in the numerator, here I have a cos A common, I take that out, and the same goes with the denominator too. Cos A is common, I take that common, right? So when I take out cos A out, here when we remove cos does not mean there's nothing, you should write it as 1 there. So cos A into 1 by sin A minus, when you remove this cos A, you're still left here with 1. So same goes here. So cos A outside 1 upon sin A minus 1 by cos A outside 1 upon sin A plus 1. Now these two get cancelled. We are left with 1 by sin A minus 1 by sin A plus 1. Now look into the RHS. It is written in terms of cosecant. Now we have seen the identities, right? 1 by sin A is going to be cosecant A, and just replace this value now. So cosecant A minus 1 by cosecant A plus 1, which is nothing but the RHS.